Assalamualaikum. My name is Muhammad Abdul Aziz bin Azmi. My metric number is 076526.
Nama saya ialah Rajul Syazwan bin Rajasu. Nombor metrik saya ialah 078186.
Assalamualaikum. My name is Nur Anisha Tasha binti Muhammad Nishal and my metric number is 077880.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nurul Izziani binti Bukhari, nombor metrik 076420. Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present abstract about Intel Core i5 8350 ultra low power. Announced in August 2017, the Intel Core i5 8350 ultra low power is a power efficient quad-core security operation center designed for laptops and ultrabooks based on the Kaby Lake refresh generation. The Core i5 8350 ultra low power has 4 cores, but its basic clock is 1.7 GHz, which is lower than that of its direct predecessor, the Core i5 7300 ultra low power, which is still dual core. With a maximum frequency of 3.6 GHz, Turbo Boost also provides decent single core performance in the near term, though it is now called Intel UHD Graphics 620. The GPU is still the same as the Intel HD Graphics 620. DDR4 2400 or LPDDR3 2133 and dual channel memory are supported by the integrated memory controller.
Everyone, now I will present you my part, which is the CPI equation. Before we know the CPI equation, we should dive into the CPI. Why the CPI matter? So the CPI is a fundamental measure for performance processor because it directly related to how quickly instructions are executed. Imagine that instruction is a specific amount of word and each clock cycle is each tick, like that. These are the factors that affecting the CPI. First is instruction mix. Different type of instruction have different execution time. Meaning that simpler execution take less clock cycle, where the complex instruction take more clock cycle. Second is the pipeline efficiency. Modern processor use pipeline to apply the execution of multiple instructions. This make the instruction to become more easy to process and take less clock cycle. Next is the price prediction. Processor try to predict the outcome of prices if there is a conditional jump in code, like if as an incorrect prediction can lead to pipeline stall and higher CPI. This is the factor of affecting CPI. Next we build into the CPI equation. So what is the CPI equation? CPI equation is a clock cycle per instruction. This formula is CPI equal to total clock cycle over total instruction. Let's reimagine this to understand better. Let's say we have a program with the following instruction. Instruction 1 is arithmetic operation, takes 2 clock cycle. Instruction 2, data movement, takes 1 clock cycle. Instruction 3, logic operation, takes 3 clock cycle. Instruction 4, arithmetic operation, takes 2 clock cycle. So the total instruction will be 4 and the total clock cycle will be 8. Then the CPI will be calculated like this: 8 over 4 equal to 2. That's it. So lower CPI mean better performance. So we need lower CPI to enhance our processor performance. That's why the CPI all about. Thank you.
Today I'll be presenting about Amdahl's law. Amdahl's law was first proposed by Jim Amdah in 1967. It is used to calculate the performance of the computer by testing some part of it. For the formula, the Amdahl's law is speed up Fn, F equal to fraction of program that is parallelizable, and N is parallel processor. Okay, the formula is 1 over 1 minus F plus F over N. The assumption is parallelizable works distribute perfectly onto N processor of equal capabilities. Okay, for the calculation is effective physical core utilization. This data I got from the Intel Vitium Pro, and the F equal to 0.719 and N equal to 4 core. Okay, for the speed up, we input the data 1 over 1 minus 0.719 plus 0.719 over 4. equal to 0.528. Okay, from this data, we know that if some program was input by a user, the computer will use the time to calculate this around to finish the program around 0.528. Some people say about if we add more processor in this, it will not increase the speed up, but then it will increase. But at the max point, it will not more increase. It will be linear until the.
For conclusion, in exploring evolution and performance metric in computer architecture, it is important to know the fundamental architecture of processes such cycle per instruction application of Amanda law and benchmark tests in order to make best decision and optimization to create a great processor as perfect as possible.